My name is Najwa and I'll be giving the introduction of Green Theorem and Stokes Theorem. Green Theorem establishes a relationship between a two-dimensional vector field's line integral over a closed path in the plane and its double integral over the region it encloses. Green Theorem is also a subset of the much broader Stokes Theorem. This theorem could be used to approximate any Wedge type used to modify a line integral into a double integral, and it can also be used to transform a double integral into a line integral. There are numerous applications in physics with Green Theorem. One is where it can solve two-dimensional full integrals, which state that the sum of fluids exiting a volume equals to the total of all fluids exiting an enclosing area, and be used to compute the area and centroid of plane figures only by integrating the perimeter in plane geometry, and particularly in area surveying. Moving on with Stokes Theorem. Stokes Theorem can be thought of as a more complicated version of Green's Theorem. Stokes' theorem can establish a relationship between a surface integral over a surface S and a line integral around a surface boundary curve or a space curve. Stokes' theorem is a three-dimensional counterpart to a Green theorems. For example, we can take by interpreting a line integral in three-dimensional, consider there is an inconvenience of the wind whilst during our flight. If it is positive, the wind was generally beneficial, and that we assume it appears to circulate around C in the direction that we specified. Meanwhile, if it is negative, it tends to circulate in the opposite direction. Thus, with Stokes' theorem, Stokes' theorem is a line integral of the tangential component of F around the boundary curve of S is the same to the surface integral of the normal component of F's curls, based on the formula that is given in the slide.
Next is about the similarities and relationship between Green's theorems and Stokes' theorem. Green's theorems and Stokes' theorems are both related to closed line integral with surface integrals. Green's theorems give the relationship between a line integral around simple closed curve C in a plane and double integral over the plane region R bounded by curve. Meanwhile, Stokes' theorem gives the relationship between a line integral around a simple closed curve C in space and surface integral over a piecewise smooth surface S. The relationship between Green's theorems and Stokes' theorem is that Stokes' theorem is a generalization of Green's theorem from two-dimension to three-dimension. Stokes' theorem is regarded as a higher dimension of Green's theorems that describe positive and negative surface orientation, while Green's theorems equal to Stokes' theorem for positive surface orientation.
There are 5 mathematicians and physicists who are contribute to the discovery of Green's theorem and Stokes' theorems. Firstly is George Green. He is a son of Nottingham Baker, who was born on 14 July 1793. He is an English mathematician and physicist. He shows his interest in mathematics at the early age of 8. Green's life is worth of attention because he almost entirely self-taught, since he only had 1 year of formal schooling. Then he went to work with his father. His contribution in Green's theorem started when he wrote an essay on the application of mathematical analysis to the theories of electricity and magnetism. Next is Augustin Louis Cauchy. He was born on 21st August 1789 in Paris. He is a French mathematician, engineer, and physicist who contribute to the several branches of mathematics, such as divergence and convergence of infinite series, probability, differential equation, mathematical physics, and determinant. His contributions of Green's theorem is when he proceeded to use the Green's theorems in the process to prove the Cauchy theorem on the integral of a complex function around a closed curve. Then, William Thomson. William Thomson, also known as Lord Kelvin. He was born on 26 June 1824. He was an Irish-Scottish mathematician, mathematical physicist, and engineer, born in Belfast, Ireland. He is a genius child. He learned mathematics with his father at a very young age, and he always had a knowledge on the latest update in certain subject. His contribution in Green's theorem is at 1945, when he rediscovered Green's theorem and popularized it for the future mathematician when he worked in Paris laboratory. The fourth person is George Gabriel Stokes. He was born on 30th August 1819 in Screens Island. He was an Irish physicist and mathematician. He mostly spent his career at the University of Cambridge as a student and also as a professor. His contribution is Stokes' theorems, when he made Green's work as a reference in his research paper. The theorem named after him because he always used the theorems as a mathematical problems on the Cambridge examinations, therefore resulting to Stokes' theorems. Lastly is George Gabriel Stokes' student, which is Hermann Hankel. He was born on 14th February 1839 in Halle, Germany. He was a German mathematician who worked on the theory of function, theory of complex number, and the history of mathematicians. Hankel is the first who published the proof of the Stokes theorem in Smith's Prize exam at Cambridge in 1861. Unfortunately, he didn't manage in any contributions in mathematics until he died at the age of 34.
Next, we will cover about the roles of George Green, William Thomson, and George Stokes in discovering these theorems. George Green was best known for his contribution to Green's theorem. At the age of 8, he was sent to the town's leading academy at Robert Goodacre Schools in Nottingham. However, during the year 1801 and 1802, he only completed 4 terms of formal schooling and worked full-time at his father's bakery. In 1828, he published his first written paper that was entitled An Essay on the Application of Mathematical Analysis to the Theories of Electricity and Magnetism. However, his work does not attract much attention because it was too advanced for people around him to comprehend. On the day he died in 1841, his work still remained unknown. It wasn't until 1845 it was discovered by William Thomson, who realized its importance, thus republished it. In 1847, Lord Kelvin collaborated with Sir George Gabriel Stokes. Together, they became interested in the work of Green and unraveled it. In 1850, Stokes learned about the discovery of Stokes' theorem through a letter that was sent from Lord Kelvin. In 1854, Stokes decided to put the theorems as one of the problems in the examination at Cambridge University. However, it was uncertain whether his students ever proven the theorem. But in 1861, the first known to authenticate Stokes' theorem was by Hermann Hankel. He was the first who provided solid evidence of Stokes' theorems.
Next is electricity and magnetism of Green's and Stokes' theorem.
In 1828, George Green first proposed Green's theorem in his book that he published entitled An Essay on the Application of Mathematical Analysis to the Theories of Electricity and Magnetism. Through his paper, he introduced a potential function for electric and magnetic fields as well as how to formulate the function using his theorem. This theorem used a mathematical approach to a physical problem without knowing or understanding of how electric or magnetic fields are worked through space. After 4 years of George Green's death, William Thomson, or Lord Kelvin, found Green's essay as a student in Cambridge and repeated it in 1845. The theorem later was presented by Cauchy in 1846. Thus, science of electromagnetism was then existed and is useful in calculating magnetics and electrics. William Thomson, that is, Lord Kelvin, and Sir George Gabriel Stokes worked together and discovered a theorem. It was later named after Sir George Gabriel Stokes, that is, Stokes' theorem. This theorem is applied to physical situations and values in laws, such as Maxwell-Faraday law and Ampere's law, and also it is used to calculate a vector field's curl. Later, Stokes' theorem and its generalized form are essential for calculating the line integral of a curve and calculating the curl of a bounded surface.
Next is the example of application in Green's theorem and Stokes' theorem.
In Green's theorem, there are 2 applications, which are classical mechanics and electrodynamics. Classical mechanics is used to determine the momenta of 2-dimensional and axially symmetric bodies, while electrodynamics is used to link between the integral and the differential Maxwell equation. The Green's theorem will be utilized to demonstrate the relationship by deriving differential Faraday's law from the integral form. The application of Green's theorem in physics, it is used to determine the energy of currents where it considers the current loops as the superposition of small loops. The energy contained with the tiny loop are shown in the figure. Next is application of Stokes' theorem, where it has first, second, and third experiment, where in the first and second experiment, it generates motional that defined by the flux rules. While in the third experiment, it indicates that changing in magnetic fields will generate electric fields, where the electric fields equation are shown as below, and it will be result in Maxwell-Faraday equation that has been expressed in differential form. Next is the application of Stokes' theorem in physics. In electromagnetic physics, it is used to determine the curl of a vector field, where the Stokes' theorem and modified form are indispensable to calculate the line of the given curve and the curl of a bounded surface. The given figure is the example that illustrates the theorem. And this is the end of our presentation on 3 main theorems. Thank you and have a nice day.